Come through, come through.
Welcome to Robot Lab 2023. This year, our mission was to design and create an assembly line that could build and test data loggers, whilst also machining the vacuum form protective covers. The team split into 3 groups, each focusing on one stage of the production line. In each cell, the teams work on a series of tasks including PLC coding, robot programming and fixture design. The PLC teams write the system logic and handshake between resources, whilst the robot teams program the robot to directly manipulate certain parts of the assembly. The fixture teams design and build all necessary fixtures to locate and secure the assembly at each stage of the process. The testing team use a Raspberry Pi to test the functionality of the sensors in the data logger. To begin the process, the RFID in each shuttle is read and rewritten to be directed towards the appropriate docking station. This differs depending on the contents of the shuttle. Firstly, the sensors need to be loaded into the correct station. These are removed from the conveyor belt and placed into the cell. The guiding pins locate the tray and a magnetic locking system holds them in place. Simultaneously, production of plastic covers can begin. The T-bar robot reaches into the vacuum former to remove the unprocessed cover and brings it within reach of the M6i. Using a Dremel attachment, the M6i cuts off the flash and drills in the holes for the screws. The processed cover is then left in a buffer to be used in the next round of production. When entering the first cell, a camera, paired with a Raspberry Pi, analyses the kitting tray to ensure all parts are present and orientated. The assembly begins by placing the PCB of the data logger into its base. This requires 2 different end effectors to complete the task. The fixture then holds the parts in place so they can safely be spun on the turntable. The LR mate can now secure the PCB using 3 screws collected from the hopper. Now assembled, the logger can be returned to the kitting tray to continue along the production line. At the next station, the assembly is unloaded and placed into the test fixture. In turn, the gyroscope, thermometer and barometer chips are all carefully inserted into the PCB using the same multi-purpose end effector. The static sensor tests are then performed by comparing the output to a reference logger. For the gyroscope, the assembly has to be shaken to test for the expected response. If any sensor fails the test, it is sent to the bin and a replacement is reinserted into the logger. The tests are then all repeated to confirm it's working. When all the tests pass, the logger is then sent back to the conveyor belt to continue its journey. The dashboard in cell 2 shows the real-time results of the sensor test, as well as the success rate of the sensors. The final cell is responsible for attaching the cover and main assembly together. Another M6i is used to maneuver the 2 parts into the fixture, and a second LR mate is used to screw the 2 parts together. The completed data logger can then return to the kitting tray. This graphical user interface shows the state information of each machine in the system. And that concludes our Robot Lab for 2023.